The universe is a vast and mysterious place. It's filled with stars, planets, galaxies, and more. Have you ever wondered what keeps everything from flying apart? What holds us to the Earth and keeps our planet orbiting the Sun? The answer is gravity. Gravity is a fundamental force of nature that attracts any two objects with mass towards each other. The more massive an object, the stronger its gravitational pull. This force is responsible for the very structure of the universe, from the formation of stars and planets to the graceful dance of celestial objects in their orbits. Without gravity, the universe as we know it would not exist. Sir Isaac Newton, a brilliant physicist, developed a law to explain this fundamental force. Newton's law of universal gravitation states that every particle in the universe attracts every other particle with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Simply put, this means that the more massive the objects and the closer they are, the stronger the gravitational force between them. We can represent this with a simple equation. F equals g times the product of m1 and m2, divided by r squared, where F is the force of gravity, g is the gravitational constant, m1 and m2 are the masses of the two objects, and r is the distance between their centers. We've all experienced gravity when we jump or drop something. Objects fall to the ground because of Earth's gravitational pull. This pull causes objects to accelerate towards the Earth at a constant rate, known as acceleration due to gravity, denoted by the letter g. The value of g on Earth is approximately 9.8 meters per second squared. This means that for every second an object falls freely, its speed increases by 9.8 meters per second. This acceleration is the reason why objects gain speed as they fall. Section 4. Mass versus weight, untangling the difference. We often use the terms mass and weight interchangeably, but they are not the same thing. Mass is a measure of how much matter an object contains. It is an intrinsic property of an object, and remains the same regardless of its location. Weight, on the other hand, is the force exerted on an object due to gravity. It depends on both the object's mass and the strength of the gravitational field it is in. Your weight on Earth is different from your weight on the Moon, for example, even though your mass remains the same. Section 5. Buoyancy, the upward push. Have you ever wondered why some objects float in water while others sink? This is due to a force called buoyancy. Buoyancy is the upward force exerted by a fluid that opposes the weight of an immersed object. Archimedes' principle states that the buoyant force on an object is equal to the weight of the fluid displaced by the object. If the buoyant force is greater than the object's weight, the object will float. If it's less, the object will sink. This principle is essential in shipbuilding, hot air ballooning, and even in understanding why clouds float in the sky.